Thank you everyone for joining today. We're going to explore an AWS perspective of continuous deployment, progressive delivery, and experimentation. My name is James Bland and I'm the Global Tech Lead for DevOps here at AWS. In my role, I work with AWS customers to understand the different challenges they are having in accelerating their software development efforts, and I work with AWS service teams and partners to bring forth solutions to those different customer challenges. So, we live in a technologically advanced society where customers have become accustomed to having everything they want right away. People can purchase products and goods online and have it delivered next day, and even same day. We can even order food from local restaurants and have it delivered to our homes, all from an app. Customers no longer want to wait months or even years for a new feature. They want it now. And if you can't deliver, it opens the doors up for your competitors. When I talk about this in the context of customers, I'm referring to both external customers, which could be customers of your customer, and internal customers such as business stakeholders and users of the application and/or service. To delight customers and win new business, we need to release features faster while de-risking deployments, because we don't know what we don't know. There is a need to anticipate what customers want and be able to experiment and accelerate quickly. Amazon CEO Andy Jassy refers to this as the minimum lovable product. Because this cannot simply be viable, your customers need to love it. What this means for orgs is that they are constantly under pressure to do more with less. Technologies such as cloud has helped by significantly compressing the time to acquire and provision cloud resources, but it has also brought about its own set of challenges. It's easy to say release faster, but without the capabilities in place to release safer, we might be accelerating problems and causing additional downstream impacts, affecting customers and derailing the time we spend on creating that minimum lovable product. While customers want things faster, we need to balance that with capabilities that can release safer and allow teams to experiment with ideas to find that next feature that adds additional value and benefits for the end customer. Before we go too far, I want to level set on a few terms, just so we're all on the same page. So, what is continuous deployment? There's a lot of confusion between continuous delivery and continuous deployment. With continuous delivery, the deployments are scheduled, so that if you have a weekly, bi-weekly, or monthly cadence, that's where you pause and you wait for that time or change window to come, and only then you release the change. But when it comes to continuous deployment, the last time any manual intervention happens is at the point where the code is peer-reviewed and, once accepted, flows automatically all the way to production. There's no need waiting for any kind of cadence or schedule like what happens in continuous delivery. To reiterate, continuous delivery has a manual step, and continuous deployment automatically gets deployed to production. Progressive delivery is an extension of continuous integration and continuous delivery. Progressive delivery adds safety features and experimentation to de-risk deployments into production. We'll talk more about capabilities to achieve progressive delivery a little later in this talk and how it's used to de-risk deployments and experiment with feature releases. Progressive delivery came about to accelerate deployment of features. What I mean by this is that continuous deployments give you capabilities to test and deploy faster, but without a way to experiment, you'll have no way or no idea if your feature is lovable by your customer. Additionally, every feature that is not lovable by your customers accumulates tech debt. Those dormant features cause applications to become bloated over time and also drain staff resources having to manage and maintain features that customers just don't use. So progressive delivery tries to address this by allowing for quick iteration of features and provides important signals to remove features customers are not in love with. From a high level, experimentation is the ability to test business ideas in a controlled fashion. In the context of progressive delivery, experimentation includes the ability to target specific user groups and/or market segments. An example would be targeting a specific user population, such as all users with an email address that ends in yahoo.com, or all users from a specific company or a customer company. Experimentation as progressive delivery system allows for the collection of metrics and data to help make better business decisions. Now that we've defined continuous deployment, progressive delivery, and experimentation, let's talk about the different capabilities necessary to achieve these. A/B testing runs two versions of your application simultaneously and is targeted at identifying which version is able to satisfy a specific objective better than the other. An example would be an advertiser showing two different ads and running an A/B experiment to determine which ad has more click-throughs and purchases. A/B experiments are not limited to ads or UI differences, but this is the area that it tends to get the most use in. Within AWS, A/B testing can be done with application load balancers and/or Route 53. Traffic splitting is a technique that splits the network traffic to different targets based on a percentage. In a simplistic design, there would be versions, one with the original software and another version with a new feature or variation of the original. Traffic would be split between the different versions. What I just said may sound very similar to A/B testing, but where it differs is that you can test more than what is displayed to the end user. Multiple variations of backends or other software features that are not necessarily exposed to the end user can be experimented with. In AWS, traffic splitting can be accomplished with advanced features of application load balancers and Route 53, such as geolocation traffic splitting, which is splitting traffic based on the user's location coordinates. No matter how much testing we do in lower environments, and no matter how similar the prod and non-prod environments are, some issues are identified only when code reaches production and receives production traffic, causing production outages and degraded services. Canary deployments are a pattern for rolling out releases to a subset of users or systems. The idea is to first deploy the change to a small subset of systems, test it, and then roll out the change to the rest of the servers. The canary deployment serves as an early warning indicator with less impact on downtime. If the canary deployment fails, the rest of the services are not impacted. With canary deployments, the application is released progressively. We start with a small group of systems and users based on the initial testing and some bake time. We ramp it up progressively until we deploy the new version of the application to 100% of the systems. A canary release is the lowest risk-prone compared to other deployment strategies because of this control. In the example on the screen, I highlight a basic canary analysis rollout. The deployment starts with 10%, does some analysis to determine the quality of the release. If the analysis detects an issue, the release is rolled back. Assuming the analysis passes all tests, the deployment is increased to 30%, and the process of analysis starts all over again. Canaries takes the approach of rolling out a little, test, roll out a little more, test, roll out even more, and test again approach. This process is to build confidence that the deployment and change will not have a negative impact on users. A blue-green deployment is a deployment strategy in which you create two separate but identical deployments. One environment, blue, is running the current application version, and one environment, green, is running the new application version. Using a blue-green deployment strategy increases the application's availability and reduces deployment risk by simplifying the rollback process if a deployment fails. Both environments are running simultaneously, which from the end user's point of view will appear to be like an instant version update from an old version to a new version. After testing, once we are confident about the new version of the application, we simply switch traffic to the new version, which now becomes the new production environment. The old version, or blue environment, can later be discarded or updated to version 2 of the code to serve as a backup in case we need to recover from a disaster. One of the benefits of blue-green deployment is that it's simple, fast, well understood, and easy to implement. Rollback is also straightforward because you can simply flip traffic back to the old environment in case of any issues. People often wonder between canary and blue-green, what is the best deployment strategy? I often recommend canary deployments to customers as canary allows for deployment safety and experimentation features all in one deployment strategy. You get deployment safety by rolling out a few servers, testing, and rolling out more. And you get experimentation as both old and new versions are running simultaneously. Regardless of which deployment strategy you use, I always recommend treating your deployments as immutable. Basically, don't upgrade a server or resource, but completely replace it. With canaries, this means a new server and new version is rolled out and added to the load balancer to take on a portion of the traffic. As canaries are added, old versions are removed from the load balancer and destroyed. Modern software practices use feature flags when releasing new functionality. Using this technique, we can hide features behind a configuration toggle, also called a feature flag, and deploy the code to production. However, since the code is hidden behind a flag, customers cannot access the feature unless their flag is turned on. There are different types of feature flags for different scenarios. So there's canary releases, where feature flags can be used to enhance and perform canary releases. This is where you are only turning the new feature on for a small percentage of the total user base, a canary cohort. Experimentation or A/B testing flags is where the feature is turned on for a reasonably large cohort of users, then study how those users behave compared to a control cohort. Then there's kill switches. As the name indicates, these types of flags are used to toggle a feature completely on or off. This can be used as a fail-safe mechanism where if something really bad happens with a new release, we can flip the switch and turn off potentially impacting features. This can also be used when the application architecture is being modernized. Lastly, there's permission toggles. These flags are used to change the features or product experience that certain users received. The difference between this and canary flags is that the user group is a canary is random, whereas permission toggles are used to allow access to certain features to a known group of customers. These could be internal or certain premium customers. Something I want to call out, feature flags should not only be for engineers. These should also be for product managers, marketing, and other personas should have the ability to turn on and off feature flags and run their own experiments. Additionally, these personas should have access to reports and data that's generated from a feature flag system. I wanted to provide an example of using feature flags to decouple service dependencies. There are certain services or systems that have dependencies on the systems and often require some type of release orchestration where all the services need to be updated or released at the same time. In my example here, Service 2 and Service 3 require Service 1 to be released first, and Service 4 is dependent on Service 3. Coordinated releases are often difficult to perform and often block teams who are waiting on other teams to complete their portion of the feature. In the case, Service 4 has to wait for Service 1 and Service 3. Feature flags help solve this problem by allowing teams to independently release changes and decouple services. So instead of having to coordinate changes, both services, such as Service 3 and Service 4, can release their changes when they are ready. And once all necessary changes have been deployed, all services can be toggled on. So we've talked about all the different capabilities to achieve progressive delivery. Now let's talk a little bit about challenges with the different approaches. A/B and split traffic requires running 2 or more versions simultaneously. This requires a complex deployment pipeline and orchestration to get right. With this approach, you need to have 2 versions running in production at the same time, which makes rollbacks, if there is a problem, difficult. Canary requires good testing to perform optimally, and a mature application telemetry is also critical to detect issues and roll back if necessary at different release gates. Canary also can be slow to fully deploy, which is especially true for large environments. Cost is a major drawback to blue-green deployments. Replicating a production environment can be complex and expensive, especially when working with microservices. An outage or issue should also have a wide-scale business impact before a rollback is triggered. And, depending on the implementation, in-flight user transactions may be lost when the shift of traffic is made. Lastly, feature flags require a large engineering effort to build a system that can accommodate different personas besides engineers. Also, if not engineered effectively, can expose security issues as end users may be able to set flags through the browser that exposes features or functionalities the company is not ready to expose. And a poorly engineered feature flag can cause downtime if the flags are not available for different user segments, such as premium versus basic users. The strategies I've talked about are not mutually exclusive. Combining some of these patterns together, you can build smart ways to test, validate features, and release with very little risk and high levels of feedback. It's very common to see feature flags for experimentation, load splitting for service resilience, and canaries to de-risk deployments and provide safety for releases. We've talked in length about the different capabilities you need. Let's transition to additional advice to level up your progressive delivery. So smaller is better. To unlock speed, you have to make smaller changes. This may sound counterintuitive, but smaller changes are easier to test and release to production. Practice deployments. In my opinion, the best way to learn is by practicing. You can't get good at deployments without actually doing them. Database is often an afterthought when it comes to CI/CD. We need to apply the same CI/CD principles we use with software changes for database changes. Test automation. The importance of testing at lower level environments is to build confidence in not only your software changes, but also in the deployment process. As you promote from each environment, you need to test your deployments and, more importantly, your rollbacks. Automate rollbacks. Sometimes accidents happen and you deploy the wrong change or didn't quite deploy the change the way you wanted to. Look to using features such as feature flags and kill switches to switch back to the old experience. The key here is to make sure that you have a rollback plan and that it is fully automated and fast to recover. The last piece of advice is around observability. As you run tests, you are executing various parts of your application code. They usually generate errors and exceptions in application logs. It is valuable to catch not only functional issues, but also non-functional issues at every stage. The sooner you can catch issues, the easier and cheaper it is to fix. The key to getting this visibility into problems is observability. We've talked in length about the different capabilities you will need and some advice on how to de-risk deployments. Let's transition to talk about how Amazon does progressive delivery. At Amazon, we use a continuous integration pipeline where we move features and functionalities from source to build, build to alpha, alpha to beta, and beta to gamma. If the environment alpha, beta, and gamma don't sound very familiar to you, think of them as dev test and stage. The point of each environment is to build confidence in the deployment and features being deployed. Lower environments prioritize quick tests that fail or error out, while higher level environments stress test the features to tease out slower developing issues such as memory leaks or performance issues. Gamma environment is as production-like as possible, including the same deployment configuration, the same monitoring and alarms, and the same continuous canary testing as production. Gamma is also deployed in multiple AWS regions to catch any potential impact from regional differences. Our number one objective for production deployments at AWS is to prevent negative impact to multiple regions at the same time and to multiple availability zones in the same region. Limiting the scope of each individual deployment limits the potential impact on customers from failed production deployments and prevents multi-availability zone or multi-regional impact. To limit the scope of automatic deployments, we split the production phase of the pipeline into many stages and mini deployments to individual regions. Deployments to each production wave start with a one-box stage. Each prod one-box stage deploys the latest code to one box, which is a single virtual machine, single container, or a small percentage of Lambda function invocations. The prod one-box deployment minimizes the potential impact of changes on the wave by initially limiting the requests that can be served by the new code in the wave. Typically, the one box serves at most 10% of overall requests by the region or the availability zone. If the change causes a negative impact in one box, the pipeline automatically rolls back the change and doesn't promote it to the rest of the prod stages. Testing in these earlier environments is not only testing code changes, but also testing the deployment process and the automation built for rolling changes back. After one box deployment and no issues are detected, a fan-out deployment begins by increasing the number of canaries within a given region. Synthetic monitoring is actively testing the deployment during and after each update is deployed. This fan-out approach is continued to each additional AZ and region following the same approach, testing after each deployment. Once the deployment process completes, we have successfully deployed a service update to production. A typical microservice might have an application code pipeline, an infrastructure pipeline, an OS patching pipeline, a configuration feature flags pipeline, and an operator tools pipeline. Having multiple pipelines for the same microservice helps us deploy changes to production faster. Application code changes that fail integration tests and block the application pipeline don't affect other pipelines. For example, an application code change does not block infrastructure code changes from reaching production in the infrastructure pipeline. All the pipelines for the same microservice tend to look very similar. For example, a feature flag pipeline uses the same safe deployment techniques as the application code pipeline. Because a bad feature flag configuration change can have an impact on production just as a bad application code change can. Using the deployment strategy I just talked about, here at Amazon, with thousands of teams leveraging microservices with fully automated pipelines, canaries, feature flags, and testing, for 2020, Amazon completed over 190 million deployments. That's around 6 deployments every second. At AWS, we have a comprehensive list of services, but none of which I talked about with Progressive Delivery would be possible without our partners. AWS partners offer a unique set of capabilities that builds on top of AWS to provide customers with solutions so they can focus on their core business objectives. At AWS, we've been long believers in enabling builders to use the right tools for the job. And when you choose AWS, you're provided with choice. You can use AWS native services to build, and you can also have access to the broader DevOps tool landscape using the AWS account with AWS Marketplace. AWS Marketplace makes it easy to find, try, and acquire the DevOps tools you need to suit your use cases. It has more than 13,000 products from over 3,000 software vendors, many of which you can try for free, and if you decide to use, will be billed through your AWS account. You can visit aws.amazon.com/marketplace to find, try, and buy software with flexible pricing and multiple deployment options to support your different use cases. The final takeaway from today's talk: we talked about advanced capabilities such as canaries as a method to reduce deployment risk at any scale while balancing cost. Blue-green for deployments where quick rollbacks are necessary and the scale of the deployments are small to medium. Then we talked about feature flags and how flags can be used by multiple personas in the company, such as product managers, marketing managers, and engineers. Plus, feature flags can be used to deploy a feature that spans multiple services with interlocking dependencies. We talked about smaller deployment sizes to reduce risk, practicing deployments to develop muscle memory, using CI/CD for databases, automated rollbacks and testing at each stage of the deployment process, and observability to understand what went wrong and detect anomalies between deployments. Then we talked about how AWS does deployments and concluded with Marketplace as the place to find, try, and buy solutions for different use cases. With all that being said, thank you for attending today. I know you had other options, so thank you again for spending your time here. Have a nice day and goodbye for now.